distance is also s1. Now from A to C, uh, returning back to C, what are the values of distance and displacement? Okay, it's easier to calculate the value of distance first. Okay, as we've distance. Okay, as we've seen earlier, the distance is just the length of the path that is followed, right? Length of the path that is followed. So the path that it followed was from A to B first. So that we'll take this length, A and B, which is S1, plus the path that is followed was from B to C. From B to C, it's S2. So this is the total distance that it covered, which is given over here. Distance covered is S1 plus S2. Okay. Now the tricky part comes here, how to calculate the displacement. So basically it's simple, it's not that tricky, it's just simple. From displacement, let's look at the definition of displacement. It represents the position of that particle from its starting point, right? Position with respect to a starting point. The starting point in this case was A. At point C, we have to find the distance from A to C. We have at C, the particle is at C now. So all that we need to do, wait, let me erase this out first. Okay, from A to C, we just need to measure the distance from A to C. So the distance from A to C is gonna be this part over here, from A to C. So the length of this arrow is gonna be this entire S1 minus S2. So the displacement in this case is gonna become S1 minus S2, because displacement in reality is the distance from the starting point. So the distance from the starting point is this red arrow that I just drew. The displacement is going to be S1 minus S2. Now let's look at the graphs of distance and displacement. Okay, so distance, as time increases, the distance will increase, so the graph will keep on rising from A to point B. This green portion represents the journey from A to B. And so as this green portion ends, the particle has traveled all the way to S1, right? S1 has been completed and this is the point B. Now after B, it moves forward to point C. It keeps on increasing, the length keeps on adding because the distance keeps on adding up. So as time further increases and the particle reaches the point C, this is the point where our total distance becomes S1 plus S2, and the difference is S2. Okay, now let's look at the displacement time graph. In the displacement time graph, at first the displacement increased, it went all the way up to S1, right? But after reaching the point B, the particle started moving back towards its original position. So the distance from the original position started decreasing, and so the distance started decreasing and reached the point C over here. This was the point B, this is the point C. Okay, this difference between the S1 and the D, this arrow was actually D, distance and the D, this represents the distance that it moved backwards. So the displacement becomes only D. This is its displacement. Okay, so basically the displacement time graph, it can increase and it decreases, but the distance time graph, it keeps on increasing. Displacement time graph, it decreases because the particle starts moving back towards its original position. So the distance from its original position starts decreasing, therefore the displacement starts decreasing, because displacement is the distance from the original position. Let's look at the gradients now. The particle, or this trolley actually, from as it moved from A to B, its velocity was constant at v. When it started returning back, the direction of the velocity, it switched, right? It became opposite. At first the trolley was moving towards the right, then it started moving towards left. So as the direction becomes opposite, the sign also changes and becomes negative. So as we look at this graph over here, at first the gradient was positive, but after point B the gradient became negative because the directions of the movement became opposite. In this graph, as the time increased, the distance started increasing because distance is a scalar and can never be negative. Okay, now let's look at a few past year paper questions. Okay, so in this question, it says that a car at rest in a traffic queue moves forward in a straight line and then comes to rest again. The graph shows the variation with time of its displacement. Okay, what is its speed while it is moving? Okay, this is a displacement time graph. So one thing that we've learned is that the velocity is actually nothing but the gradient of a displacement time graph. Okay, over here in this portion, the gradient is 0 because of it's a horizontal line, and over here as well the gradient is 0, so it's a horizontal because it's a horizontal line. 0 gradient means that the velocity that this car is at rest, but it's asking us when the car is moving. We need to find the speed when the car is moving. So it's basically this portion that the examiner is asking us to find. He's asking us to find the gradient of this line actually. So just let's find the coordinates first. This is 50 and 30. This point is 170. Gradient is y2 minus y1 over x2 minus x1. So just 70 minus 30 upon 100 minus 50. This 40 upon 50, and it becomes 0.8 meters per second. So B is our answer. Now let's move towards the next question. The variation with time t of the distance as moved by a body is shown. Okay, so this is basically a distance time graph. What can be deduced from the graph about the motion of the body? If we look carefully, at first the gradient was a bit uh, less as compared to the next part of the journey. This line has a greater gradient compared to the initial line. Okay, so let's see the speed changes as at the point D over here. It says that the speed changes. We know that the gradient represents the speed for a distance time graph, right? It's a distance time graph. So since the gradient is changing, so yeah, this is correct. The speed is changing. Distance is proportional to time. No, distance is not proportional to time because it's not a straight line passing through the origin. It is a line with two different gradients at two different parts. It starts from rest. Again, see, we've discussed this point earlier. It does not start from rest because the gradient of this line is not 0. The gradient of the line passing through the origin must be 0 for the this whatever the body is, for this body to be at rest. It accelerates continuously. You know, nothing can be said about acceleration from here. Okay. A brick is dislodged from a building and falls vertically under gravity. So okay, we have a brick. let's say this is